All right, welcome back 8th grade. This is our last video for chapter 4. We're going to talk about how to evaluate a function. This is where we're going to start seeing that function notation. So we kind of talked about in vocab function notation, but as we read this, we see the function w of x. That's what we say. That's how we say it. W of x equals 250x. Represents the number of words, which is our w of x, you can read in x minutes. How many words can you read in 8 minutes? So again, we talked about when we talked about vocab that this just allows us that if we have multiple, and I know we don't have multiple here, but if we were to have multiple functions, then I could have them each listed as their own as opposed to the function y equals whatever it is after the y equals. So all we have to do, this also allows us to show what we're substituting in without having to say like x equals, right? We're going to say that our w of x is going to be w of 8. So my function when x is 8, that's what that means, equals 250 times 8. Now, I'm not doing anything with this here. This just stays w of 8. That, again, tells me what I plugged in for x. And all I have to do is take 250 times 8. You can do that in the calculator. And we get 2,000. So, if I can type 200, or I can read 250 words a minute, then in 8 minutes I read about 2,000 words. And that's how we use function notation. So on to the next. Notice we're in function notation, f of x here. And it gives us our function, and it's also telling us our domain. So this is our domain. Remember, domain are x values. And it's asking for the range. And the way you find your range when you're given a list of your domain values is you just plug it in. So I'm going to do f of 1 equals negative 1.5 times 1 plus 4. So f of 1 equals negative 1.5 plus 4. F of 1 equals 2.5. And so that's my first one, and then I plug in the next one. F of 2 equals negative 1.5 times 2 plus 4. Negative 1.5 times 2 is, so we have f of 2 equals 3, negative 3. Don't drop your negatives. Mrs. Curran almost made a big mistake there. So my f of 2, my function when x is 2, equals 1. And then I do it for the next one. F of 3 equals negative 1.5 times 3 plus 4. Negative 1.5 times 3 is negative 4.5. So we have f of 3 equals negative 4.5 plus 4. My function at 3 is equal to 0, negative 0.5. Now, I want to point out, as you're doing this step here, this is just like when we were doing substitution property in chapter 1. Or when we double-checked our work in all of chapter 2. So, all we're doing is plugging in, substituting our x value. Alright, so f of 4 would equal negative 1.5 times 4 plus 4, and negative 1.5 times 4 is negative 6. So now we have f of 4 equals negative 6 plus 4, negative 6 plus 4. Negative 6 is bigger, so my answer is going to be negative, and then 6 minus 4 is 2. Alright, so those are all my answers, and then it says, but what is the range? And so my range is going to be, and I'm going to put them in numerical order. So negative 2, negative 0.5, 1, and 2.5. Oops, and I did curly bracket is what I want. But that is my range. And again, all we did was take the domain values and plug them in to get our range values. Okay. Now we're going to identify a reasonable domain and range for a graph. So, excuse me. If we go to our question, because anytime we see a lot of words, that's what we should go to. What domain and range are reasonable for the function? And then what is the graph of the function? So let's start with the first one. We need a domain and a range. So my thought process as I'm thinking about domain, I need to go into my, what do I know? I have 3 quarts of paint to paint the trim in my house, and a quart of paint covers 100 square feet. I know that the function is A of Q equals 100 Q. That A of Q represents the area. And Q represents the quarts of paint. So when it comes to our domain are our x values. What is the smallest x value we can have when it comes to painting? Well, we can't do negative, right? So the smallest value, our minimum value, would be 0 quarts, right? And then we've got to see if we have a max value, and we only have 3 quarts of paint. So if I only have 3 quarts of paint, my max value is going to be 3 quarts. So when it comes to my domain is that 0 is less than or equal to Q is less than or equal to 3. So we're writing this as an AND compound statement. So we're saying that Q is between 0 and 3. And so this is how we write it. So that's my domain. Well, now I got to figure out my range. Well, how do we figure out range, Mrs. Cartwright? Well, it's easy. This is where the other 2 slides come in handy. We just got to plug in. We know we have A sub Q. I'm going to plug in my minimum. So A sub 0. We'd have 100 times 0. That's easy. A sub 0 equals 0. And then I plug in my maximum. So A sub 3 equals 100 times 3. Easy enough. A of 3 equals 300. Easy enough, right? So then my range, when I go to write that range, is between 0 and 300. So 0 is less than or equal to A of Q, which is less than or equal to 300. And so there's my domain. The fact that I can only use numbers between 0 and 3. And my range is that my answers will be between 0 and 300. And then it just says, what is the graph of the function? So how do we graph this? Well, I'm going to take my domain values. I know they're from 0 to 3. I'm going to take values within that domain. So 0, 1, 2, 3. And then I'm going to plug them into our equation. So we already know 0 times 100 is 0. And then I'm going to do 100 times 1 and get 100. And 100 times 2 and get 200. 100 times 3, and we already know that that was 300. And then I graph those. I have a point at 0, 0. I have a point at 1, 100. 2, 200. 3, 300. But then that's it. And I draw a line in between those points. But that's as far as it goes. And I don't draw an arrow because it's not, my domain only goes to 3. It doesn't go past 3. And so that's how we use function notation to graph, to evaluate, to figure out domain and range. So until next time, 8th grade, have a wonderful evening or day or whenever you're listening to this.